Okay, so we're picking up where we left off. Oops. We're going to talk about concentration and molarity. And what we want to talk about now is expressing or showing the concentration of an electrolyte. And you know what an electrolyte is. It is something that dissolves in water and conducts electricity. Electrolytes are very important in biology and other places. And when an electrolyte, when an electrolyte dissolves, like say we have aluminum chloride, the concentration of each ion is going to depend on the concentration of the overall formula, what the overall molarity is. So we're going to talk about that a little bit more. So here's an example, sample problem. You're looking for the molar concentration of each ion. So this is important. The words in the question are important. Each ion present in an 0.025 molar aqueous solution of calcium nitrate. So we may need to know how much nitrate we have or how much calcium we have. So the first thing that we need to remember is that calcium nitrate, which would be written like this, we have to know how to write it. We need 2 nitrates for every calcium, because calcium is a +2 ion, nitrate is -1. And when this dissolves, it's going to break up into a calcium ion, which is aqueous, and 2 nitrate ions, which are both aqueous. That's what happens when calcium nitrate dissolves. So if we have a solution that is, 0.025 molar in calcium nitrate, what this question is asking us is, what will the molarity be of the calcium ion, and what will the molarity be of the nitrate ion? So we're putting 0.25 molar of calcium nitrate in here, and for every you can see, I scribbled the formula again down here, for every 1 mole of calcium nitrate that we have only 1 mole of calcium, because there's 1 calcium ion in this formula. So our concentration of calcium ions should be the same as our concentration of the whole thing. So I'm going to write 0.025 here, because this is a 1-to-1 ratio, 1 calcium in 1 of the whole thing. Now, we need to find out also the concentration of the nitrate ion. So, if we start out with 0.025 molar of the whole thing, and we pour it in here, and if we have, I'm going to do this in black actually, 0.025 molar CaNO3, 2. And molar is, I'm going to scratch this out, this is moles per liter. It's the same thing. And I'm going to, for every 1 mole of Ca, I realized this would have been better if I had more room, of calcium nitrate, for every 1 mole that we have of that, we have 2 moles of nitrate ions, because there's 2 of these for every 1 mole of the whole thing. 2 units of this for every 1 unit of the whole thing. This is a 2-to-1, so we're going to have 2 moles of just nitrate in my 1 mole of the whole thing. Equal sign. So these moles cancel with these. So my concentration of nitrate is 0.050 moles per liter of nitrate, if you can read that. So my concentration of my nitrate is twice that. It's going to be, we'll do it in, hey! Sorry, my dogs were fighting. So that is, the concentration of the nitrate is 0.050 molar, or 0.050 moles per liter. And this 0.05 is twice that, or double what the concentration of the calcium was, because your number of nitrates, I'm circling it, this 2, is double what your 2 to 1 ratio. So you'd have twice as many nitrates for every that you have for calcium ions.